Hello, welcome to another maths video by Maths with Sarah. So again, today we're going to be tackling a GCSE Maths question. There's two parts to this one. So the first part is working out using the mass density volume equation, which hopefully you'll be familiar with. And then the second part is using that information to then work out the height of a cylinder. So this is taken from a calculator paper, and you almost certainly will actually need your calculator to work this question out. It's question 16, so starting to get a little bit more challenging towards the back of the paper. So you're kind of looking at probably grade 6, possibly grade 7 for this style of question. And as you can see, it's worth 4 marks in total for both parts together. So as with all these videos, I would encourage you to pause the video now, have a read through the question, and have a little go yourself. If you can work it out, then brilliant. If you stuck, then don't worry about it. Just come back to the video when you've had a go yourself, or at least thought about what method you would use, and I will go through it in a minute. Okay, so hopefully you've had a chance to have a think about how you tackle this question. So the first part of the question said that we've got some concrete with a volume of 3.8 meters cubed, and the density of concrete is 2,400 kilograms per meters cubed, and it wants you to work out the mass of the concrete. Now, hopefully from this, you can see that we've got density, volume, and mass. And you'll remember that there is an equation that connects these three. Now, I don't know about you, but I am terrible at remembering equations, and I always end up needing to work them out. So I'm just going to show you a little trick that's really useful for working these equations out rather than having to memorize anything. So if we take density, the units of density are kilograms divided by meters cubed. And then if we look at the two other sections of this equation, we've got the volume with the units of meters cubed. And we have got mass. And hopefully you remember mass is very similar to weight. And so the units will be kilograms. So looking at this, we know that density, the units equal kilograms divided by meters cubed. And we notice that we've got kilograms and meters cubed as the units of both mass and volume. So we can work out from this that the density is equal to the mass divided by the volume. Now, some of you might use a triangle method. So you'll remember you have density, mass and volume, and then you can cover up whichever one you don't need to work out the rest of the equation. Now, I was rubbish at remembering which letter needed to go in which part of the triangle, so that was why I always used to rely on using the units, and then it can never go wrong with that. So I would encourage you to have a think about doing that yourself. So I'm just going to rub off these bits because I'll run out of space otherwise. So we know from this that we have got density equals mass divided by the volume. But we don't want to know the density. We instead want to know the mass. And so we can rearrange this equation. So as with algebra, we've got volume on being divided, mass divided by the volume. So if we times both sides by the volume, we will end up with density times volume equals the mass. And that's obviously what we need to work out. Again, if you're using this triangle method, then you cover up the one that you need to find out. So in this case, you cover up mass, and that will give you density times volume, which is what we've just worked out. So to work out the mass, we're going to do the density, which is 2,400 times by the volume, which is 3.8. And that will give us 9,120 kilograms. So that's the answer to the first part of this question. We've calculated the mass of the concrete using this density mass volume equation. Now, I'm just going to write this here so that we don't forget it. So it's 1,120 kilograms. So the next part of this question is looking at, so it's given you a cylinder, and it's given you some of the dimensions, but it wants you to work out the remaining dimensions. So they've told us that the volume of this concrete is 3.8 meters. 3.8 meters cubed, sorry. And that's made into the shape of a cylinder. And the base of this cylinder has a radius of 0.5 meters. And it's asking us to calculate the height. So obviously, normally the way that this would be given would be the other way around. They would say, this is the radius, this is the height, calculate the volume. But in this case, we've been given the volume and it's asking us to do the reverse to calculate the height. So we need to think about what the equation is to work out the volume. So to calculate the volume, we would normally do the area of the base times by the height. Okay, and you can see that we've got parts of this, so we've got the volume. We can work out the area of the base because we've been given the radius, and then we can use the combination of those to work out the height. So if we want to calculate the area, we're going to need of the base, we're going to need to use pi r squared. If we do that, we've got pi times 0.5 squared. So if I was doing this question, because there are multiple parts, I would recommend that you leave it in terms of pi. That will probably be what your calculator will come up with through default anyway, and that gives you pi divided by 4. But just if you prefer to use the numbers, that's fine. Just make sure you do it to enough decimal places that you don't end up with rounding errors. If you do convert it to a number, then that will give you 0.7854, about 0.8. So we've calculated the area of the base, and the next step is to calculate, is to work out what the height is. So we know what the volume is. We know the volume is 3.8. And so to rearrange this equation, we're going to divide the volume by the area to calculate the height. So if you rearrange this, we're just dividing both sides by the area of the base, and that will give us the volume over the area. And the volume we've said is 3.8 meters cubed, and we're dividing that by the area of the base, which in this case we use pi divided by 4. And that, when you put that into a calculator, comes out as 4.883 meters. So around that to 4.9 meters. So I just realised there should be a 3 in there, so it actually rounds to 3.8 meters. And we can have a think about whether or not this answer seems logical. So if you were looking at this, although it's obviously not going to be drawn to scale, you can think about, does the height of about 5 meters seem reasonable? I would say yes, it does. If you'd got 5,000 meters or 0.005 meters, you might be questioning, or hopefully you'll be questioning it. But an answer of about 5 meters seems pretty logical to me. So I think this was quite a good question. So it got you to use various different equations and rearrange them a bit first, rather than just asking you to calculate the volume straight off. It's actually asking you to understand how to calculate the volume and then do the reverse, which is a really good way of testing that you actually understand how to use the equations rather than just blindly plugging the numbers in. So hopefully that's made that question really nice and clear for you. I would encourage you to subscribe to my channel so that you get the first look at any new videos. And if you have got any particular questions that you would like me to go through, then just drop me a message. Thank you for watching.